friends. Welcome to Coding Garden. Welcome to an introduction to TypeScript. So in this video, I'm going to go over the basics of TypeScript. I'm going to show you how to set up a folder in a project for TypeScript, and we're going to talk about all of the basic features. And this really is essentially a crash course. It's kind of all the things you would need to get up and going in a basic React app with TypeScript, or a basic Express app with TypeScript, or a basic Vue app with TypeScript. So that's my goal for today, is to give you the basics so that you can get up and going in a project with TypeScript. If you want to follow along with this, you absolutely can. You can clone this repo. And all of the code and examples that I write, I'm going to put on a separate branch. So even if you're following along on YouTube, you can clone this repo down and write code along with me, and it won't be spoiled by the repo unless you look at the solutions branch. So let's go. Let's talk about TypeScript. I absolutely should go to typescriptlang.org. Here it is. TypeScript is JavaScript with syntax for types. The tagline here is, it is a statically typed superset of JavaScript that compiles to plain JavaScript. Now, if you don't know what the word superset means, it's demonstrated in this picture, in that everything about JavaScript that you know right now, everything about it, the way you write functions, the way you access and modify variables, the way you work with objects, all of that is valid TypeScript, but then TypeScript adds just a whole bunch more on top of that. It adds additional developer features that are then stripped away at compile time. So what that means is when we're writing TypeScript, it's really basically types and extra things sprinkled on top of our code that give us better developer features like IntelliSense and autocomplete support, and can also warn us about things that we do in our code that may result in an error if we hadn't taken into the types. And so that's one of the main things I want you to take away from this, is any valid JavaScript is TypeScript. So we're going to learn the basics of TypeScript. And I will say that the TypeScript website, the TypeScript Lang website, has amazing documentation. So honestly, you don't need to watch this video. You could just go to these documentation here, learn about TypeScript, and they do a wonderful job. And we're going to keep referring back to those docs as we go. But these bullet points here were taken from this article, and I'm going to read them to you just to really talk about what TypeScript is. So TypeScript is a static typed checker. It detects errors in code without running it. That means, like, TypeScript is not a runtime like node.js. TypeScript is essentially like a meta language. It's a language on top of a language that allows us to detect errors in our code. And it doesn't actually run the code. It just is able to statically analyze the code. And it does not affect the runtime behavior of JavaScript, meaning the TypeScript code that you write isn't going to change what the resulting JavaScript code would return, or the kind of errors that it would throw. That doesn't happen because TypeScript gets stripped away. So what happens is you write TypeScript code, and then it gets converted into JavaScript before it can be run. And this is true for no matter where you're using TypeScript. Now, it is possible to configure TypeScript so that it won't run if there are errors, or like it won't finish the compilation if there are errors. But this is important to note, that all of the TypeScript you're writing is getting converted into JavaScript. And when you compile TypeScript into JavaScript, all of the type information gets removed. So there's no runtime type checking built into TypeScript. It's all compile time type checking. There are libraries you can add that would give you runtime type checking, but that's not built into TypeScript itself. And that leads into this next thing here, that TypeScript also doesn't provide extra runtime libraries. So like there's no extra standard library or anything that is like a TypeScript specific function call or a TypeScript specific library. There's none of that. It truly is just types sprinkled on top of your JavaScript. And that leads us to our question here: should you learn JavaScript or TypeScript first? And I argue you should learn JavaScript first, and so does the TypeScript documentation. I'm going to read this piece right here. Because it's really important, and a lot of beginners might get confused once you start learning TypeScript, and then you're trying to search the web to fix errors that you're getting in TypeScript, or trying to figure out how to do things in TypeScript. But this one section in the docs are really good. I'm just going to read it verbatim. So the answer is that you can't learn TypeScript without learning JavaScript. TypeScript shares syntax and runtime behavior with JavaScript, so anything you learn about JavaScript is helping you learn TypeScript at the same time. And then this next paragraph just talks about, if you look at Stack Overflow, there are 20 times more questions asked about JavaScript than there are about TypeScript. And so if you are having an issue or having trouble with something, it might actually be JavaScript, a JavaScript problem that you need to solve, not necessarily a TypeScript problem that you need to solve. And they have this example here. So if you find yourself searching for something like how to sort a list in TypeScript, the answer is you sort it the same way you would in JavaScript. So TypeScript is JavaScript runtime with a compile time checker. And so that's just important to note as you're going through your TypeScript journey. And we're going to talk about it later, but it also applies for libraries. So let's say there's a really nice library that you like to use with your JavaScript code. That will work with TypeScript. If types are not provided, you'll have to do some things to make sure that you get type completion for them. But you still can use any JavaScript library with TypeScript. So someone asked about CoffeeScript in the chat, and I think it is important to talk about because when TypeScript first came out, everyone was comparing it to CoffeeScript. They're like, oh no, this is the new CoffeeScript. I'm not going to spend all my time learning it because it's just going to get outdated and not used at some point. That is not the case. TypeScript has been around since, I think, 2014. Let's look it up on Wikipedia. So TypeScript has been out since 2012, and many production applications have been written with TypeScript since then. When it first came out, people were wary of it. It was initially, people were slow to adopt it. I would say these days, most JavaScript devs have to touch some kind of TypeScript, whether they're using a library that has type definitions or the code base that they're working in uses TypeScript. So TypeScript is extremely popular. And it kind of is the de facto way to build a project, a medium-sized or larger project. So just a quick note on prerequisites. In order to follow along here, you should have written some JavaScript in your life. You should know about variables, loops, conditionals, functions. You should know how to do all of that stuff with JavaScript because we're going to be showing examples with those, but we're going to be sprinkling some TypeScript on top of it. And you should have npm and node.js installed. So let's set up a project. And like I said earlier, if you want to follow along, just clone this repo down and we'll run all of these commands in the folder that you cloned down. So the first thing we're going to do is create a package.json. So if you do npm init -y, that will create a package.json, and it won't ask you any questions. It'll just choose all of your defaults. And now this package.json is where all of our dependencies are going to be listed. So just like how you manage dependencies with a JavaScript project, we're going to do the same thing here. And the first dependency we need is TypeScript. And you'll notice I'm installing it with -d. So that installs it as a development dependency. So if you look at my package.json now, you can see that TypeScript is a dev dependency. But what's nice about that is that now gives us the tsc command. That's how we're going to compile our TypeScript code. But now that we have it installed in this directory, when we run commands from this directory, we can use it. So that's great. The next thing we need is a tsconfig. And you can just create this right in the editor. Say new file, tsconfig.json. And for now, we're just going to leave it empty. So we're going to add a few properties as we go, and we'll talk about what those properties do and also show you the documentation on all the extra stuff. But for now, just an empty JSON file with some curly braces in it. Great. And then the last things we need to install are nodemon and ts-node. So if you're familiar with backend JavaScript, typically we use nodemon to make sure that the server restarts after code has changed. And ts-node is essentially a way of running TypeScript code through Node where the compilation step is transparent to you. So you don't have to constantly compile your code. ts-node has hooks into node.js so that it will compile it on the fly and then run that JavaScript through Node. So we're going to install nodemon and ts-node in this directory as well. So if I do npm i-D, nodemon and ts-node, those will be added to our dev dependencies as well. And so if we look in our package.json, we have those. Good to go. All right. Let's see our first type annotations. So let's dive into this example.ts file. And we're going to see our first type annotation on a string. So if I was writing JavaScript, I could say something like, let my name equal CJ, like this, right? Totally valid. What TypeScript gives you are type annotations. So we just sprinkle some annotations on top like this. And we say, hey, my name is a string. Great. Well, what do we get now that we have that? Well, the TypeScript compiler is able to see that we've defined it as a string, and so if we try to do something else with it, it's going to say, hey, you can't do that. So for instance, if I tried to say my name equals 42, I literally get an error from TypeScript that says number is not assignable to type string. So this is the first time you're seeing the real benefits of TypeScript. Essentially, we take this language JavaScript that's usually pretty loosey-goosey, and now we've added rules on top of it so that if I try to do things like this, the editor warns me. So that's a thing. And these are type annotations. Essentially, you have your variable name with a colon followed by a type. And all of the types are provided. So you have Boolean. And you can do it like this. We also have a number, so I'll say favorite number, and you do it like this. For the most part, this is how you're going to do basic type annotation. And you also can do type annotation on functions, right? So let's say I have a function called add that takes in a and b and returns a plus b. And then let's say I want to log the output of add with the number 4 and the string 2. So right now, TypeScript's not saying anything is wrong, right? It's like, you can see that there's a little hint that says this implicitly has the any type. That means we haven't put a type on it. So TypeScript's like, oh, that could be anything. And so if we try to add a string and a number, right now, TypeScript doesn't care. It's like, yeah, sure, you can do that. So if we explicitly put the type on the parameters here, then TypeScript can help us out. Because then it could be like, whoa, you said you only wanted a number there, but you're trying to pass in a string. So this says argument of type string is not assignable to parameter of type number. So we're seeing that error displayed for us that we're passing in the wrong thing. And so really what I probably want to do is something like this to get the right thing. Okay, so I'm writing my TypeScript code, and I am getting these errors in my editor, but that's because I'm using Visual Studio Code, and Visual Studio Code has built-in support for TypeScript. So if you're not using Visual Studio Code and you're not seeing these things, there's likely a plugin you need to install, but you actually get that for free with VS Code. But now let's actually turn this TypeScript into JavaScript. And one thing we can do is just from the command line, we can run the tsc command, the TypeScript compiler. And so because I have TypeScript installed as a dev dependency right here, if I do npx tsc, it knows that it can find that tsc command in my node modules folder. So because I installed TypeScript, that's why I get access to tsc. And then I can just point it at a file. So, hey TypeScript, please compile example.ts. And we should see now an example.js file. Awesome. Now, tsc is the TypeScript compiler, and it has a lot of options to it. There's a lot of different things you can pass in. And actually, there's a ton of them, which is why we have this tsconfig.json file. So there are settings that I want to specify when compiling the code. And so I can do that in this file, and then I don't have to specify specifically the file that I want to transpile. So let's get our first configuration set up here. So you can see in the generated example.js file, it actually converted all of my lets into vars. You can also see that all of the type annotations just got stripped away, right? It literally just pulled those out. It's like, that's not JavaScript. We don't need that anymore. And then it converted these lets into vars. And that's because by default, the target is either ES3 or ES5. And we don't want that. We want to target a more modern version of JavaScript. And we can do that in our tsconfig. So in the tsconfig.json file, there is a compiler options. So put that in there, and then inside, we want to specify the target. And here, I want to specify ES next. And you can see as I start typing, it does have autocomplete, so just make sure that you have the right camel casing in there. So we'll do target as ES next. And now if I want TSC to pick up these settings, don't specify the name of the file. So now if I just do npx tsc, it's going to automatically look in the folder to see that config file and then use those settings. So if we look at the generated code, now you can see that it left my let declarations behind, because it's like, oh, you want the latest JavaScript. I'm not going to convert it into older JavaScript. So we're good to go there. Another setting that I want to specify is the output directory, because right now it's just putting that file right next to my other file. And if you have a really big project, that can get really messy. So the other setting we want here is outdir, or out directory. And I'm going to specify that as /dir. So this specifies not dir, dist, /dist. So this specifies the folder called dist. So dist is short for distribution. This is a pretty common pattern. You might also see this called build, but dist is pretty common as well. You can call it whatever you want. But essentially now, when I run the TypeScript compiler, it is going to put all of the generated code in a folder called dist instead of right next to it. So for now, I'm just going to delete that JavaScript file. And then we'll rerun this npx tsc. And when that's done, now we see that we have a dist folder that has our JavaScript code inside of it. So you definitely want to set this up just so all of the generated JavaScript files don't interfere with your existing code. I think someone asked about it earlier, but essentially this dist folder, you actually don't want to commit to GitHub. You only want to commit your TypeScript files, and wherever your code is run, it will be compiled there, whether it's on another developer's machine or whether it's getting built into a Docker container or before it's deployed or something like that. You basically don't commit your dist folder to Git. So you also want to make sure, and I should already have this set up if you clone the repo, but in your gitignore, you would want to make sure that dist is in there somewhere. And it is. You can see that it's in the one that I added, it has a bunch of Node.js related things, but you just want to make sure that that word is in your gitignore, so that way you're not actually committing the generated code there. Okay, so I've been running these commands from the command line, but let's make it easier on ourselves, and we're going to add it to our package.json. So in our package.json, there should be a section for scripts. You should see test in there, but I'm going to get rid of that, and I'm going to add one called build. And we're going to explicitly do what I was doing here, except when you put commands inside of your package.json, you don't have to put npx. So I can literally just put tsc. And so now, if I run npm run build from the command line, that in turn runs tsc, which looks at that config file we created and then generates the JavaScript code. All right, now that we know how to configure it, we actually are going to gradually add more settings here as we need to, but for now this should be enough. Let's talk about inferred types. So you may have noticed I defined this function called add, but I didn't define a return type. And so if you're coming from like Java or C#, you might be familiar with the fact that you actually have to say, oh, hey, this function returns a number. So that's another way we can annotate our code, is to say a specific function will return a specific type. But TypeScript is able to infer that based on the operation that's happening. And so actually, I'm going to comment this code out, and we're going to write it again with inferred types. And really, the only reason I showed you this is because I wanted to demonstrate the type annotation, but you also get inferred types with variables. So I actually don't have to put :string right there. And if I do that, TypeScript knows that this is a string because the right-hand side is a string assignment. And if I try to put something else in it, like this, I'm going to get that same error we saw earlier because it has inferred the type from the right-hand side. So this is nice because you actually don't have to put types everywhere. You only put them where you really need them. Same thing goes with all of these. So because the right-hand side has a specific type, that means that the variable gets created with a specific type. So if you try to overwrite it with the wrong type, you're going to get an error there as well. Now, this type cannot be inferred because I've defined this function. I have to define what type it is taking in. However, the return type can be inferred. So if you look at A, which is a type number, and B, which is a type number, TypeScript knows that A plus B returns a number. So if you look at add, you can see this notation right here, which basically says this function returns a number. And if we put it in a variable, like this, and then we log that out, this, if you hover over it, is a number. So again, like we can't put other stuff into it. We're going to get an error there because TypeScript knows that the return value of that function should be a number. So these are known as inferred types. Essentially, if you're calling a function and it has a return type, you don't have to specify the type. If you're defining a variable and you're initializing it with a value, you don't have to define the type. And so typically, this is how we write our TypeScript code. So even though I always want to make sure that these are strings and numbers, I can leave the type off because TypeScript can infer it. Okay, let's take a second to talk about the compiled code. So this is the code we wrote, and we saw that it got generated here in the dist folder. But let's write some code that actually would result in a type error, right? So let's try to put my name, so to put a number into my name like this. Right now, TypeScript says number is not assignable to type string. But this is not a runtime error. This is a compile time error. Because if I compile the code again, so if I run build, we see that an error popped up. So TypeScript is definitely like, hey, you're doing something weird here. But if you look at the output, it still output that code. So this is another thing about TypeScript, right? Is it's not affecting the actual like generated code or the code that's going to be running for your application. It generates that error at compile time. So when it is actually turning it into JavaScript. Now, if you had like an actual like syntax error, like let's say I just have like a weird curly brace just hanging there, that should prevent it from getting converted. Like if I run this, let's see. Yeah, this is honestly, it's a JavaScript error because this is not valid JavaScript syntax. But if we look at and then you can see that it didn't make it past that because it was a syntax error. But anything that's not a syntax error, TypeScript is still technically going to output. So if I do this, we see the type errors, but it's still outputting it. So this really just drives home the point that TypeScript gets stripped away. It's warning you when you're in development, but at the end of the day, when your code is actually running, you can do whatever you want with it. So I'm going to get rid of that. And then I'll show you some options. So in this tsconfig, we can actually add some options that prevent it from generating the code if there are type errors. So one of the options we want to add is strict mode. This doesn't have to do with actually creating the code, but you'll see if I add strict true, the generated code is going to have use strict at the top of it. And that's just JavaScript strict mode. If you want to know more about this, just search the web for JavaScript strict mode, but we can add that. And then Bajosi has it as well, which is no emit. And so this disables errors from emitting, but you could also do no emit on error and set this to true. So if there was a type error, don't emit the code. So let's actually delete this JavaScript file. And then we'll go back in and say, do the bad thing. But now if I try to run the build, it didn't generate any code. You can see that the dist folder is still empty. So this is really just a developer precaution because you're preventing that code from actually getting generated if there were TypeScript errors. And this is really strict. I would say probably most code bases have this setting because you do want to make sure that your code is correctly typed and checked. But for some developers, this could be an issue because maybe you can't fix all of the type errors because you're dealing with legacy code or something like that. So you may or may not want to turn this on. I'm going to leave it on for now, and then I'm going to actually fix my type errors. So if I just get rid of that line of code, now when I run build, I don't have a type error, and it does actually output the code as well. Great. So that was a quick aside. So another interesting thing that will be caught with inferred types, and thanks Monkey Fuel for the question, who says, would inferred types catch an array that holds strings when it should be numbers? But let's say we have an array of numbers, like 4 and 7 and 13 and 42. The inferred type of this is an array of numbers. If I highlight over that, you can see it's a number array. We haven't talked about this syntax yet, but I'm going to show you some more examples with it. But basically, we are saying that this is an array of numbers. And so if you try to push things into this array that are not numbers, you're going to get a type error. So if I do numbers.push and I try to push in the word wow, I get an error because argument of type string is not assignable to parameter of type number. So I'm trying to push a string into something that got inferred as a number array. So it'll catch it in that scenario as well. Okay, so we've seen some examples, we've generated the code, and we saw how I edited this config file to have various options. If you look in the TypeScript documentation, they describe all of the various properties that you can add and edit in this config file here, but there is also a command you can run that will automatically generate this with some good defaults. And so I'm going to run that command now, and it's actually going to replace this file. So if I do npx tsc-init, that will generate a file, but it won't because it says we already have one, but that's okay. So I'm just going to delete this tsconfig.json. and then run this command, and it will generate it for me. And you can see that it has some defaults here. So the target is ES 2016, common JS modules, strict mode, ES module interop, skipping the libcheck, and force consistent casing file names. So all of those are the defaults if we look at it. So that's great. So I'm going to change it back to what we have. I think we had ES next right here for the target. And then we need to specify the out directory. But what is nice about generating this file using that command is all of the things that you might need to specify are in here that you can then just comment out. So this outdir is what we wanted to specify earlier. So if I comment this out and then put dist, now it has the same settings. No emit on error. So if I comment that out, now we're going to have that same setting as well. And you can see there's a lot of other settings in here. And also, I believe, yeah, if you go to this link, it has more information about these settings as well. So if you're starting up a TypeScript project, you would probably want to do this just so you can see all of your possible options and get some good defaults. Okay, so we've learned about basic type annotation and then inferred types. Now let's talk about union types, because these are essentially things you would use in scenarios where it's not always one type. And let's actually use our array of numbers example. So let's say I wanted to allow numbers and strings in here. So let's create a variable called numbers and strings. And then we'll just throw my name in there, and we'll throw my dog's name in there. My dog's name is Panzer, like that. What's nice, though, is this does get an inferred type, and we'll see what the type got inferred to. You can see here that it's string pipe number array. So this pipe is actually how we do union types. So again, we just learned about inferred types, so I actually don't have to put the type here. But if I were going to write the type out, it would be like this. I could say string or number, and that is of an array. And so now I can put strings and numbers in this array. You can do the same thing with just like a basic variable. So if I say the answer, this can be a string or a number. And it starts off as 42, but because I defined it with this union type, I can also say the answer equals string 42. So right now it's erroring because it's const, but if I make it let, then I don't get a type error because I said, hey, this can be a string or a number. Yeah. Put that back there. So this is union types. This is really useful when you're dealing with API responses because sometimes it might be undefined, sometimes it might be null, sometimes it might be a string. And so when you're defining those types, you can use those union types as well. It's also useful for functions if you, like this add function technically could work on strings. So I could do number or string, but then I'm going to get some weird behavior. But basically, you use this when something has to have more than one type. All right, now let's get into the fun stuff. And this is probably where most of the TypeScript you're going to be writing are for objects and interfaces. So far, we've just done primitives. We've just done basic variables, basic functions. Now let's actually talk about how to describe objects. So there is this thing called an interface. So if I create an interface called person, I can describe what a person has. I'm going to say that a person has a name that is a string, and a person has a favorite number that is of type number. And so now this is essentially a description of a person object. So if I have a person object here, and I give it a name of CJ, and it has a favorite number of 42. Now, this object is just a plain object. This isn't a class instance or anything like that, but actually is of type of this interface because it has all of the same properties that are of the same type described by this interface. And so if I had a function called greet that takes in a person, and I can say they should be of type or of interface person, and then I'm just going to return a string that says hello, and then person dot name. And so this is another benefit of TypeScript, is that you get type completion. So because I said this function accepts an object that will adhere to the person interface, TypeScript knows that, hey, it can only be one of two things, either favorite number or name. In this case, I'm going to do name. And then if I log greet right here, that should say hello CJ. Well, actually, no, we have to invoke it. So if I invoke it with this object here, that will say hello CJ. So let's not do that. Let's compile the code. And then I'll show you how to run it, because we actually haven't run it yet, but we should run it. So this is the compiled code. And then you can see down here, it stripped away that interface. Like the entire interface is gone, right? The interface was right there. Basically, JavaScript doesn't need that interface because it's just a description of the type. It doesn't help with the actual running of the code. So that entire interface got stripped away from the code. And then it's just this. But if I want to run this code, I can run it with node.js because it is just JavaScript code. So if I did node dist / example.js, that will actually run the code in that JavaScript file. And of course, I mean, we've talked about this, but if I try to run that TypeScript file, I'm going to get a syntax error because Node is expecting JavaScript syntax, right? So the moment it sees this, it's like, I don't know what to do with that type annotation. So if you want to run this code, you have to run it with Node. So if you do Node and then point it at the generated file, it'll actually run the code. Earlier, we also installed ts-node. And ts-node is essentially, it just adds some hooks into Node.js so that it can actually run TypeScript code, but it still has to be transpiled. And so what you could actually do there is if you did ts-node and then point it at a file, in this case, I have to do npx because we installed it as a dependency. But if I do that, it'll still run the code. But you'll notice it takes a second because it actually has to transpile the code and then run the code. And ts-node it's kind of the same thing as chaining these commands, like running the TypeScript compile and then running the actual JavaScript file. So we ran the code, it works, but what you may have noticed is we just passed in this object literal here, right? So when we define the function, we define it as taking in an object that adheres to the person interface here. But this doesn't have to be a class instance. In TypeScript, this is known as duck typing or structural typing. And actually, this isn't a TypeScript concept. This is a concept that is used in a lot of different programming languages. But essentially, this object, because it has all of the properties that I've defined on the person interface, TypeScript knows that I can pass it into this function, and it doesn't complain at all. However, if I go and add something else like dog name, then I'm going to get an error because dog name is not in the interface person, and in the interface person is what this function is accepting. We can look at the type error, argument of type that is not assignable to parameter of type person. Object literal may only specify known properties, and dog name does not exist in type person. This is the point where I complain about TypeScript errors because this was a mouthful, and ultimately this last piece right here, dog name does not exist in type person, that's really the error message that is important, and that's telling us what's wrong here. So that's your first tip for reading TypeScript errors. Usually scroll all the way to the bottom, and that usually will describe what you did wrong, though it sometimes isn't all the way at the bottom, but that's just something to think about. But because this is not on the type, it's throwing that error, and I can't actually have that property on there. Great. So next, let's talk about optional properties, because sometimes you may want it so that some instances have this property, some don't, and that's known as optional properties. So if we redefine this interface with an optional property, dog name, like this, that makes it so that a person object may or may not have this dog name property. And so right now, this object that I'm passing in doesn't have the dog name property, right? It is undefined, but this allows it to be undefined, and I can still access it here. But let's say I actually want another function called greet person and dog. And Jicom Gaming, thank you very much for the upgraded sub. That's awesome. So this takes in a person. So we define a function called greet person and dog. And now we want to access that person name. Let's try to do it. So hello person name and their dog person.dog name. Right now, TypeScript isn't complaining, but dog name could be undefined. And I guess that makes sense because technically it's not a type error if you pass undefined into a template string. But usually what you would do is something like this. So if person.dogname has a value, then we do that. Otherwise, let's just greet the person alone. And so defining the property like this basically makes it so that it doesn't have to be on there, but it can be on there. So if I now invoke this function with greet person and dog, and I pass it an object that has a name of Chris and a favorite number, oh, not Chris, favorite number of 13. Okay, so we passed in the dog name as blue, and then now let's compile and run this code. So I'm going to do it with ts-node. We'll just pass in example.ts. But again, I have to do npx here. And you can see hello CJ and then hello Chris and their dog Blue. We just made up the dog name Blue. Chris actually doesn't have a dog named Blue. Those are interfaces. They describe objects. You're going to have objects all over your code. JavaScript has a lot of objects in it. And so you can use interfaces to describe what should be and shouldn't be in those objects. All right. Before we move on to classes, let's actually talk about type. And Ryan has the question. What is the difference between a type and an interface? I know that you can extend interfaces, but what else is there? Yeah, so let's actually look at this type keyword, because I believe we actually can say type person. It's like this. Might not have the... I think this might be the syntax, but I'll have to comment out the interface. And then favorite number is of type number. Duplicate identifier. Yeah, so let's actually define it like this instead. Comment this one out. And then also have dog name, and that's optional string, like that. So the rest of the code doesn't complain. And then if we try to run it, it still runs. So in this scenario where you're defining an object type, an interface and a type are like one and the same, but you can do other things with a type. And let's actually talk about that now, because I don't think I planned on talking about enums, but a type is like kind of can be used in a similar way. But let me show that. So for all intents and purposes, these two things do exactly the same thing, but there are other scenarios where you would use a type over an interface. And let's actually do it on the person here. So if we do something like streamer type, and this can either be affiliate or partner, like that. So you'll notice, like, I could have defined streamer type as a string, right? Because both of these are strings. However, that would have allowed any string. But now that I've defined it as this, it actually can only be one of two things. It's either affiliate or it's partner. And what I can do is I can extract this out into a type. And so I could say type streamer type is this. And then I can use that type right here. So yeah, David has it. So basically we extract it out as its own little type, and now I can reuse it all over my code base. And you'll see we're getting some errors now though, because I made this a required property. It's not optional, which means down here I do need to specify streamer type. But I will get type completion. So because I said this can be one of two things, either the string affiliate or the string partner, then I have to specify it that way. You can do it there as well. And then if we run the code, should work. But essentially what we've done is we've defined a type that is like a union type of specific values. You wouldn't really use an interface to do this. And Knowledge Gable Programmer is mentioning that interfaces can have methods. Yeah, so you could have, I don't know, they have a time method, current time method. And we can say that this is a method that returns a date object like that. Yeah, so I wasn't going to talk about this because I was really just describing properties that objects have. Technically, you can say that an object needs to have a function on it. And in this case, this is saying that it needs to have a function called current time that returns a date. So if I threw on here a current time and returned a new date, it adheres to that interface. And I'd have to do the same thing over here. Now, this is where we're getting into like why you would want to use something like classes or object-oriented programming, because then I wouldn't have to redefine this for multiple instances. But the question is, can I put a method on a type? And I think you can. I think you can. Let's try it, though. Yeah, nothing wrong with that. Works just fine. But I would say the canonical way of doing it is to use an interface. Basically, if you're describing an object, use an interface. If you're describing other things, you can use a type. Yeah, and you can also make the, I'll mention that, you can make the methods optional as well. So if I did this, just like how you make properties optional, that means that the person object doesn't have to have a current time. That actually would be good to demonstrate where we might get a type error. So let me show this. So if I do that, and then now inside of greet, we say, hello person, it is, and let's put the time in here. So if I do person dot current time like this, this gives me a type error. So because I said current time is optional, this says we can't invoke that because it might actually be undefined. In this case, I would have to wrap this in an if statement. So if person.currentTime is defined, then do that. Otherwise, return hello person.name. And then I could also use it down here. So hello person and their dog. It is, and then person.currentTime. But I'm going to get that same type error because I need to make sure that it actually exists. So I would say if person.currentTime, we can do this. Otherwise, do it like this. And now when I run the code, we should get the time of both. Yeah, cool. Yeah, and so like technically you could have done it like this. Yeah, so this is optional chaining. This is not a TypeScript feature. This is a feature of JavaScript, the newer JavaScript. But what this says is if this property is not defined, invoke it. However, it would mess up our string. It would say it is undefined instead of it is current time. So there's a time and a place for optional chaining. This is basically how we would do that so that our code still outputs good stuff. So on the point of interfaces versus types, there's a good section in the TypeScript handbook that I'll link to. But it basically says the key distinction is that a type cannot be reopened to add new properties versus an interface which is always extendable. How does a TypeScript server understand code logic? Does it continually run the code on every change? Yes. So if you're when you're in development, you would do that. Basically, you would actually do nodemon, which behind the scenes uses ts-node. So you can see right there it's using ts-node. And then if I change the code, just like that, it saw that it needs to recompile it and then rerun it. In production, you wouldn't do that. If this were production, I would build it first, and then in production, it would just be running the node process. But yeah, in development, basically, it has to recompile it every time the files change. Yeah, so that's why I like nodemon, is it automatically picks up ts-node. So if you look at my package.json, I just have nodemon as a dev dependency, but automatically, whenever I run it, it knows, and actually when I pointed at a TypeScript file, it knows that it should use ts-node. And specifically, I have ts-node installed. So if I didn't have this installed, I believe nodemon would actually throw an error. So at this point, we've learned a ton about TypeScript. Let's jump back into our package.json because I've been running these various commands from the command line, and I want to show where we should put those in our package.json. So we already have the build command. The build command takes our TypeScript code and then outputs it to a specific directory that it outputs specifically JavaScript files. We also could have a start command, and this is basically what we would run in production. And in production, we just want to use node. So in production, we would say use node, go into the dist folder and grab that example.js file and run that. Great. And then what you'll commonly see in code bases is also a dev script. So this is for when you're in development. And what you actually do here is just say nodemon, and then point it at your main file, your entry point. In this case, it's example.ts. And nodemon works in conjunction with ts-node. It'll see that you've pointed it at a TypeScript file, and it'll know to use ts-node under the hood. And anytime the files change, it'll rerun and recompile that TypeScript file. So usually your package.json will look like this. You have like a build script, a start script, and a development script which constantly recompiles while you're in development. And so now that I've done that, if I do npm run start, that will just run the code from the dist folder where it got compiled to. If I do npm run build, that'll compile it. Usually you would run build, then start. And if I'm in development, I do npm run dev, and now it's just going to sit there and watch, and anytime my files change, it'll recompile them and rerun them. So ts-node is the middle ground between TypeScript and Node. So, and it's if you read their documentation, they call themselves a just-in-time compiler. Basically, anytime the TypeScript code is about to be executed, it gets compiled into JavaScript, and then they send that JavaScript code over to Node.js. User in the chat, INFG Codex, brought up a good point. Technically, a lot of things will actually look at the main here, and we can specify that to be, in this case, I'm going to specify it to be our TypeScript file. I don't think you would set this as main unless this is like a backend express app and you know that it's going to use main to determine how to run it. I'm going to set this as example.ts, and what that would allow me to do is to just say nodemon. And now nodemon is going to look at main and know that it needs to run that file. So now if I run npm run dev, it should see that the main file is example.ts. It does, and it's able to run that code. Great. All right, next up, we're going to talk about classes. And so the class keyword was introduced to JavaScript, ES 2015, and the way it works in JavaScript is the same way that it works in TypeScript, but there are a few extra features that aren't supported everywhere yet that I'll show you as well. But essentially, classes allow us to define a blueprint for objects that we're working with. So far, you've seen that we basically have this person interface, and then if we wanted persons, we just manually created an object with all of those properties. When you use classes, you can basically define a blueprint for a person that you can create a constructor for and have default methods and various things like that. I'm going to comment out all of this code that we've written so far so we can define a class that does a similar thing. So let's say I have a class person, and I want it to have all of those properties that the interface had as well. So I would say that it has a name, which is of type string. It has a dog name, which is of type string. It has a favorite number, which is of type number. And right now this is complaining. Property name has no initializer and is not definitely assigned in the constructor. So basically, like, I've defined this class, but by default, all of these properties are going to be undefined. But a class can also have a constructor. And the constructor is essentially a function that gets called when you create an instance of that class. And what we can do here is basically take in these three values and put them onto the instance. So I could take in the name, the dog name, and the favorite number. I think there might be shorthand syntax like that, but we're going to do it manually. String, string, number, and then we assign it. So we say this.name equals name, and this.dogname, and then dogname equals name. And this is saying, hey, that's not a property. I spelled it wrong. It needs to be a capital N. And then favorite number is favorite number, but I actually want this to be this dot. Cool. So basically, whenever we create a person, we're going to call this function. Internally, it's going to create an object that has all of these properties set to the values that I passed into that function. And so let's see an example of that. So now I can say CJ is a new person, takes in the name CJ, the dog name Panzer, and the favorite number 42, just like that. And so now CJ is actually an object that has all of these properties. So we can see CJ is of type person, and if I do dot, we can see what properties we actually get access to. Oh, you're totally right. I made an error. Yeah, thank you. I'm Google. This dog name should be dog name. And actually TypeScript, like my editor was telling me that. My editor was saying dog name is declared, but the value is never read. Because basically I referenced the wrong variable name there. Yeah, good call. Good call. Cool, yeah, so now we have an instance of CJ. We can do various things with it. I'll make another basic function called greet that takes in a person. And in this case, I can just define it as type person. And in this case, person refers to the class that I've defined. So I've commented out the code we wrote earlier for the interface. Now this specifically corresponds to the class that I defined. And this can do something like hello person.name, like that. Let me show you some shorthand syntax. It was mentioned to me in the chat that you could do this, but basically I've defined that this class should have all of these properties, and then I manually assign all of these properties, but there actually is a shorthand for that. So if instead I define my constructor like this, I'm going to comment this out so you can see that one. But if I put the word public in front of each of these, I can get rid of this definition here, and this basically does the same thing. Ultimately, it defines that I am going to have these properties on the instance itself. So this is a nice shorthand. The code's a bit harder to read. I'd probably write it like this, something like that. But this is a shorthand to say I actually want these properties on the instance itself. And the code should work in exactly the same way. And actually, let's generate this code to see what we get, because I don't know if this is supported in the latest. We can see that we're targeting ES next, so I actually am curious what code gets generated when we run this. So let's run build. Yeah, so that's like super new syntax. But it's interesting, and actually this goes right into what Windward Hive was mentioning that says you can get rid of this .name. And so when I put that public keyword on there, it actually did this for me as well. So it gets even easier. Technically, I don't need this code either. I can literally just write my code like that. And then behind the scenes, when it generates the code, it's going to create those properties. It's going to assign them in the constructor. Yeah, this is crazy. Okay, so let's rerun the build. And we can see it here. Look at that. Very nice, very nice. Okay, I will say this is like much newer syntax. I actually haven't seen this a lot in the wild, but as long as you have the right target in your tsconfig, you can use this all you want. So someone in the chat mentioned that in the code that's generated, I can actually strip out the comments as well. Let's see if we can find it. Comments. Remove comments true. Let's comment this out. So now the generated code is not going to have all of my commented code. The generated code will only have specifically the code that needs to run. So if I run the build, and we look at the generated code, look at that. It's only exactly what it needs to be. All right, that's the basics of objects. Do know that like kind of the way I'm using them here, it's very similar to interfaces, but the main difference is that we now have a more generalized way of creating these objects. You also can combine interfaces with classes. I'm not going to get into that. If you want to know more about like working with classes, working with interfaces, extending classes, implementing interfaces, look up a course on object-oriented programming. But essentially all of the stuff I've shown you here will then be applied to that. The one thing that I will show you though are access modifiers. So if you look in the TypeScript documentation on classes, there are various access modifiers that we can use on our properties. So you saw in my first example, and actually we can use this example, I made everything public. And what that means is in the outside world, I can access all of those properties. So here I have access to person.dogname, person.favorite number. But I also can define protected properties. So protected, let's call this internal secret. And this is a type string. And then now whenever I create the person, I can pass in my secret. like this. But because that is protected, it means it can only be accessed internally and by classes that extend that class. But like I said, if you want to know more about that, look up a course on it. But if I try to do person.internal-secret, I cannot access it. That is only accessible in the code running in here or in the code running from an extended version of this class. And then the last thing you have is private, which is only accessible inside this class. So we'll create another property on here. But it's a private, super secret. And now I can't access that either. So if I do person.super secret, I don't even get access to it. It's only accessible inside of this specific class. If you want to know more about this, check out the TypeScript documentation. I'll have links to all of this. All of this is in the repo as well. All right. Oh yeah, they're static. Ugh. Okay. One more thing. Ryan reminded us of static. So static properties, again, get into object-oriented programming. They are not instance properties. They are properties that are accessible on the class itself. So if I had something like static genus Homo sapien. First of all, I don't know how to spell Homo sapien. Second of all, is that a genus? What do we consider Homo sapien? Species. Let's go with species. Static is also a thing you can use, but like I said, it's only accessible on the class, not the instance. So for instance, I can't do person instance, for instance, I can't do person instance dot species. That's not a property. But what I can do is capital P person dot species because it's static. It exists on the class itself, not the instances that I create. And then what was also mentioned in the chat is you can combine these. So you can have a public static or a protected static or a private static. All of that means the same thing, but just in terms of it being static rather than an internal instance property. Okay, like I said, this isn't a course on OOP. You can learn a whole lot more about that in the TypeScript docs in any course that talks about object-oriented programming. All right, next up we're going to talk about generics. And this is, I would say, more advanced usage of TypeScript. I would say if you're just writing basic React apps, you probably don't have to deal with generics that much, and the same thing for Express. But every now and then, you might want to do something that involves generics. And also, when you use code that behind the scenes is using generics, you'll know how to identify it here as well. So let's see an example. So we'll have a function called, I think we'll do sort numbers. And sort numbers will operate on a specific type. And, well, let's call it sort items. And it operates on a specific type, and it takes in items which are an array of type T. So T is our generic here. So we're not saying number or string or Boolean or even person. We are saying some custom type called T. Really, this can be anything. It's kind of like a type variable. But the tradition is you use the letter T to correspond to type T. And I can say that this returns an array of type T items. Could try doing items.sort. We get A and B. Yeah, and then really I probably would just take in a sort function here, or a compare function. And then I can define the compare function as well, which is a function that takes in A, which is of type T, and B, which is of type T, and ultimately returns a number. This is getting really complicated. It's probably too complicated of an example, but let's talk through it and then show how we would use this. So this code looks, Ryan says my brain just melted. I'll show you how we actually use this thing. And T is not a keyword. No, T is, think of it as like an argument to a function. You can call it whatever you want. Here I could call it my array type. And this doesn't even have to be predefined. This can be literally whatever you want. Think of it like an argument to a function, argument name on a function. Call it whatever you want. But like I said, when you look at other people's code, they use the letter T because it's like generic type. But let's show how we would actually use this. So if I wanted to do sort items, and let's say I had numbers, and this was an array with a bunch of numbers in it, so like 42, 3, 77, 13, 104, and 82. So I have an array of numbers, and let's say I want to sort them. I could do sort items, and then I have to tell it what the type inside is going to be. So if I say sort items of numbers, now, because I've specified what that type is, the items argument needs to be an array of that type. So it needs to be, not numbers, number. It needs to be an array of that number. So now I've typed it so you can see, okay, this accepts an array of type number and then a comparison function, and it will return an array of number. But I could pass in any type here. So right, if I do a string, now it's a function that accepts an array of string and a comparison function that takes in A and B. So these are generics. And in this case, I'll do it with type number. I can pass in numbers, and then I need my comparison function, which will just do A minus B, like that. And then now sorted numbers should be the sorted version of that, because behind the scenes I'm calling sort and passing in my comparison function. Okay, and then this is just complaining because I already declared numbers somewhere, I think. Let's get rid of that. Cool. So again, to reiterate what just happened there, I basically call my function. I pass in the type that I'm expecting the other things to be, and then now you can think of it like that type argument kind of like flows down. So now items must be an array of that type, and the comparison function must be a function that takes in 2 arguments of that type. Yeah, and so in a second when we show the React example, we'll show how they're using that behind the scenes. And what's up, Trash Dev? Welcome in. Yeah, we're teaching TypeScript to all the newbies, and we just talked about generics, and that's all I'm going to say about generics. It'll be easier to see when you're using libraries that use generics behind the scenes. But to show here, like this is now like a general purpose sort items function, because now I can do something like, let's say we have an array of names. We got CJ, we got Trash Dev, we got Ryan Roga, we got Loco 86, and let's say I want to sort these names. Now I can do sorted names is sort items. In this case, our type argument is string, and then we pass in names, and then we pass in a custom comparison function. So we get the A string and the B string, and we want to do a.locale compare with B, like that. And then now we can log the sorted names, like that. Let's run the code. It sorted it, yeah. So we have the array of sorted numbers, 3, 13, 42, 77, 82, 104, and then the array of sorted names, CJ, Loco, Ryan, Trash Dev. And basically our function here is using generics because we can run it on any specific type. And I guess I didn't talk about this earlier, but this is a type description for a function. I'm describing a function that takes in 2 arguments of type T and returns a number. I don't know if I guess I did have an example of the method earlier where I just described its type. I'm sure the answer is yes, but can you use that pipe modifier on generics? Yeah, so you could do, well, yeah, it's called the union type. I don't know the exact syntax. You can do a comma separated syntax, so you basically could pass in multiple type arguments. So now this code down here is broken because it's expecting a secondary type. So you can have multiple type arguments. Can you do I don't know if you can do a union type though, because I don't think it would be able to infer which is one over the other. You could probably do it like this. So accept the 2 types in and say that it returns an array of either T or S. So you'd have to do it like this, and then now you could pass this in as number and string. Like obviously this code doesn't make sense anymore, but now I have 2 type arguments, and I'm using those type arguments as a union type on the return value. Yep, this is where all that neat documentation comes from. Basically, other developers either wrote their code in TypeScript or they wrote type definitions for their JavaScript code. Can you add a default type on a generic declaration? I've never done it, but apparently you can. Oh, you know what? I saw this in Keasley code. Yeah. So you can do it like that. So this says if you don't pass in a type, I'm going to assume that the type is number string. Yeah. But when I was looking at the, so Keasley is the library we're using for the database on Arduino app. And in their source code, they had this because they had some custom types you could use, like generated column and stuff like that. All right. At this point, I believe I have covered everything that you will come across in your first week of using TypeScript. There's a lot more to it, and there's a lot more really cool things you can do with it. But for the most part, everything I've covered is kind of what you're going to be seeing in the TypeScript apps that you're working in. These last things I'm going to talk about are ways of telling TypeScript that you know better than TypeScript. And the first are type assertions. So if you're working with a library that doesn't have types defined and you want to do specific things on it, you could define a type or import a type from somewhere else and then use the as keyword. So if you have some expression and then you say as some type name, you're basically telling TypeScript that you know better than it, and you're basically saying this thing is of that type that you're defining it. But again, that is just a compile time check. Because you've said that this should be this thing, TypeScript takes your word for it, and if at runtime it's not that thing, you're going to get a runtime error. Yeah, so this is just showing an example of, like, you couldn't say as on something that it knows that it cannot be. You would get a TypeScript error here because it's like, but a string can't be a number. So you can really only use it on scenarios where the return type or the expression type isn't defined, or if you want to tell TypeScript that it should be another thing. So the as keyword is pretty useful there. Yeah, and Limeotes has a good one. It's like yelling at TypeScript with an exclamation point. You're basically like, I know better than you. In this case, TypeScript would say, you don't know better than me. You can't do that. But in this scenario, document.getElementById usually just returns an HTML element, and you know that the element you're getting back is an HTML canvas element. So that's why you're saying, hey, TypeScript, we're actually getting a canvas element back here, not just a regular HTML element. Okay, the other thing is, and what we haven't shown is the any type. And so if you don't know what a type is, or you don't feel like defining an interface, or you don't feel like defining a class, you can literally just put the word any, and I will show an example of that. So in this case, if I say person is the any type, this code still will run, and I'm just laughing at it. You have a cat, which is of type unknown, and then you turn it into a number because you told it that it was unknown. There's an any key? Yeah. Just press the any key. So in this case, I removed the person type here, and so now person can be anything. And I guess we're not calling it anymore, but if I were to log greet with CJ, that works just fine because I said person could be anything. But I also could call greet with the number 42, and I'm not getting a type error here. And that's because I literally told TypeScript that, hey, this can take anything, which means like 42 is the number 42 is anything. This object is anything. And this actually would result in a runtime error if I ran this code, right? Because name is not a property on numbers inside of JavaScript. So this would say cannot access proper, well, actually this would just be undefined. It wouldn't be a runtime error, it would be undefined. If I'm trying to do something interesting like invoke a property, that could be a runtime error. But the any type is useful if you're converting old JavaScript into TypeScript, because you can put the any type everywhere and then gradually define interfaces and classes and gradually introduce types to your code. I will say you should avoid it at all costs. Like if this is a new code base, you should try your darndest to define interfaces and classes everywhere, because the any type basically removes all benefits of TypeScript. It can't do things like detect if a function is going to break based on what you pass into it, if you're using the any type. But it is a way to get around errors if if that's happening. I mentioned that we could call this function with a number, but the other thing to note is like now that we've specified the any type, we don't get type completion. So if I just do person dot, TypeScript has no idea what that thing can be because it can be anything, so we don't get type completion, which is why you do want to define your interfaces in your classes and everything else. The next type you can use is unknown. And so the unknown type represents any value, and it's similar to the any type, but it's safer because it's not legal to do anything with an unknown value. So if you declare something as unknown, it literally cannot be used. You can see in their example here, they said A was the any type, and sure, you can access anything on it because it's the any type. And then if you specify that it's unknown, you can't access any properties with it. And so yeah, this is useful when describing function types because you can describe functions that accept any value without having any values in your function body. You could also say that it returns an unknown type. So json.parse can also return anything because it takes in a string and creates an object from that. But if you don't know the object you're going to get back, you could specify the unknown type. And we saw a lot of examples in the chat where people were basically saying value as unknown, and then they use the as keyword for some other type, and that actually would let you say call a string a number. Let's see that example because it's actually pretty funny. So if I do this, it's like no, it's a number and string don't overlap. But if I say, oh well, it's unknown, and then it's a number, so now I've declared x as a number. And you can see that it has all of the properties of a number, but this is going to result in an error because hello is actually a string. So yeah, this is a double type assertion. I'm like, I don't know what that is. Oh, actually it's a number, but actually it was a string. But now I can build it. It should build just fine. But if I try to run it, that will be a runtime error because toFixed is not a function on a string. So all of that to say, you have to be careful with these. Use them where you should. Don't do things like this that will result in runtime errors. Use them to basically get around hard to fix type errors or get around things that you can't fix right now but will eventually fix later. And then the last one is the never type. And this says, when narrowing, you can reduce the options of a union to a point where you have removed all possibilities and have nothing left. In those cases, TypeScript will use a never type to represent a state which shouldn't exist. So this is an example of like a switch statement on a specific type. So you have a type that is called shape that's either circle or square. And if you do a switch on that type, it will never be anything else, according to TypeScript, because according to TypeScript, it can only ever be circle and square. So this default here is a scenario where that will never happen for the most part, but it could happen. It could happen because it's JavaScript and anything can happen for the most part. I don't know. Anything can happen. And so here we're specifying it as the never type because this code should never actually run, and this will never actually be a thing that we can use. Yeah, and I guess in their example here, they're just showing that if in the future, if we add another shape, so if we add triangle, now we get a useful error that says, hey, you have not handled the triangle type in your switch statement here. And so this never keyword is basically for future you when you go to edit this thing and you need to use it. I've never used it. Yeah. Lastly, and really these should only be broken out if you can't do anything else. If you haven't figured out anything else to do, then you can use these ts-ignore or ts-nocheck comments. But let me show you what they do. So for example, if I do something that doesn't make sense, so if I have my other name is CJ, and we'll make that a let variable so we can reassign it, and I want to put the number 42 inside of it, of course we get a type error. Number is not assignable to type string. But if I really want to say, hey TypeScript, you don't know what you're doing, let me do that. I can do / at ts-ignore, and now TypeScript doesn't complain. I can literally do anything. And this really is the hey TypeScript, I know better than you scenario. But this can result in some really weird bugs, especially if code later on is expecting that to be a string or something like that. rFire is asking, why would you ever want to do that? There are some scenarios where maybe you're using some other library, or maybe you can't figure out the exact way to express a type. This will come in handy. But like I said, it kind of is like a last resort. And this is another thing you would use if you're converting a JavaScript code base slowly into a TypeScript code base. Every now and then it might just be too much work that you just ts-ignore it, because you know, like, your code is tested and it does technically work, but you just haven't expressed the types in the right way. You can use that. And then what you probably never want to do, but what you could do, is you can put a ts-nocheck at the top of the file. So if you do this, now there is no TypeScript enabled at all in this file. And so when I do things like this, TypeScript doesn't care at all. Yeah, so debugging in a hurry, there are various reasons why you would do this. I would say probably the main one is you're converting old JavaScript code into TypeScript, and you come across things that you don't know how to express in TypeScript just yet. But I basically have disabled all type checking by putting this comment on there. I can still use the features of TypeScript, so I can still use all this stuff. But at the end of the day, this is not going to emit any type errors, and you can see that it's not even erroring out when I do this. So, like I said, those are like worst case scenarios, but you can break those out if you really need to. Okay, I'm gonna go now. I'm sorry we didn't get to the examples, but we'll get to them at some point in the near future. Maybe we'll do it on Thursday.